Linear inequalities. We're talking about relationships that are not equal. A linear inequality in two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign with either a greater than sign, greater than or equal to, less than, or less than or equal to. Okay, this you will recognize as a normal linear equation in slope-intercept form with a slope of 1 and an intercept of -3. To make it an inequality, all we've done is replace the equal sign with the greater than sign. The solution of an inequality in two variables is an ordered pair that makes the inequality true. That means an x and a y that when plugged into the inequality, like y is greater than x minus 2, an x and a y that will make this statement true. A linear inequality in two variables has an infinite number of solutions. The solutions can be represented in the coordinate plane as the set of all points on one side of a boundary line, and this dotted line here is your boundary line. This yellow shaded area, all of it, this is where the set of all solutions lies. So the solutions are not here in the white area. They're in the yellow area above the dotted boundary line, and we're going to talk about what a dotted boundary line means. Identifying solutions of a linear inequality. How do we know if a pair, an ordered pair, is a solution? Well, the same way you check if an ordered pair is a solution to an equation, you check to see if the ordered pair makes the inequality true. Okay, so we want to know if 1, 2 and -3, -7 are solutions for the inequality y is greater than x minus 3. Let's first try 1, 2. So x is 1, so we plug 1 in for x, y is 2, and the statement is now 2 is greater than 1 minus 3. Is this true? Let's simplify 1 minus 3. 1 minus 3 is a -2. Is 2 greater than -2? If the answer is yes, then it is a true statement. And if it is a true statement, then it is a solution. So yes, it is a solution. How about these two? Well, let's go ahead and put -7 in for y, and let's put -3 in for x. And simplify. -7 greater than -3 minus 3. What is that? That's like combining -3 and -3. That's -6. Is -7 greater than -6? The answer is no. So this is not true. And if it's not true, it's not a solution to the inequality. So this one is, and this one is not. Is 3, 6 a solution for y is less than or equal to 2/3 x plus 4? Pause the video and do this yourself. Okay? Pause. All right, hopefully you have gone through this yourself. And what you should have done was to plug in 6 for y. And the inequality is less than or equal to 2/3 x. And instead of the x, hopefully you put 3. So 2/3 times 3 over 1 plus 4. And we get 6 is less than or equal to 2 plus 4. 6 is less than or equal to 6. And that is true because of the inequality that is used here is a less than or equal to inequality, giving us the option of the two sides being equal. If this were just 6 is less than 6, this would not be true. But since it is less than or equal to 6, this one is true. So please understand the distinction. Okay, let's first look at the graph of linear inequalities. I'll go ahead and read this to you. The graph of a linear inequality in two variables consists of all points in the coordinate plane that represent solutions. The graph is a region called a half-plane that is bounded by a line. All points on one side of the boundary line are solutions, while all points on the other are not solutions. So in the first example that we have to the right, we have the inequality y is greater than 3/2 x minus 1. And what you see is a dotted line or a dashed line. We use a dashed line when we make the boundary line for all inequalities that have a greater than or a less than inequality symbol. What this means is that the points that are on this line are not solutions. The only solutions are in the region above the line because it is greater than. And in the example to the right, we see a solid line. And the inequality is y is less than or equal to a negative 3/2 x plus 1. It is a solid line because of the inequality symbol being less than or equal to. And what that tells us is that all of the points on the line are solutions to this inequality, as well as the points that are in the shaded region. So that's an important distinction to make. Dashed line for greater than or less than, solid line for greater than or equal to or less than or equal to. So how do we graph an inequality in two variables? Well, you're all very familiar with graphing an equation in slope-intercept form. So we use those skills to graph the boundary line. So here's the inequality, y is greater than x minus 2. We're going to just change that to y is equal to x minus 2 in order to create the boundary. Okay, so just like you would do with a slope-intercept form, you find the slope, and the slope is 1, and the y-intercept is negative 2. You graph the negative 2, and you use the slope of 1 over 1 to go up 1 over 1. And you'll find that this will be the boundary line. Now, we're going to make a dashed boundary line to represent the fact that it is a greater than, not a greater than or equal to. And then we're going to shade everything above the boundary line to show that all of the points that are in this area, in this region, in this half plane, are solutions for this inequality. Then we're going to check to make sure we're right by choosing any point on this side that's shaded to make sure it works in the inequality. The easiest point to check if it's in the shaded region is to use 0, 0. And what we'll do is we'll use the point 0, 0 to check and see if it works in the inequality y is greater than x minus 2 by plugging in 0 for y and 0 for x. And when you simplify, you do find out that 0 is greater than minus 2, so that you know 0 is a solution, and we have shaded the correct area. You could check 1, 1. 1 is greater than 1 minus 2, and you'll get 1 is greater than minus 1, and that again is true. So you know all the points on this side are correct. So how do we graph? How do we graph our own line? Okay, well, as we saw in the last example, the graph or the boundary line we make by pretending that we're actually graphing an equation and not an inequality. So in this one, we graphed the equation y is equal to 1/2 x plus 1 by finding the intercept of positive 1 and then using the slope up 1 over 2 to make a line. And I'm going to straighten this line out for you so that it is a better representation of the line. So this has a slope of a positive 1/2, and you can do a better job because you're doing it by hand. and the y-intercept of 1. And now we consider, okay, since it's a less than or equal to, what we will do, and I'm going to use the highlighter because I'll be able to shade easier, is we're going to shade everything that is underneath the boundary line. So all of the points that are beneath the line are all solutions to the inequality. All of the points on the line, since this is a situation that is less than or equal to, are also solutions. Well, let's test. Again, we have 0, 0 in the region. Let's test out 0, 0 and see if it works. That means that y is 0, y is equal to 1/2 times x, which is 0, plus 1. And instead of the equal sign, we're not going to have an equal sign. We're going to have a less than or equal to sign. And go ahead and simplify. 0 is less than or equal to 0 plus 1, which is 1. 0 is less than or equal to 1. We know that we shaded the right area. Okay, let's summarize. Inequalities, let's do this one first, that have greater than or less than signs are graphed with a dotted line. The ordered pairs on the dotted line are not solutions. Inequalities that are greater than or equal to or less than or equal to are graphed with a solid line. The ordered pairs on the solid line, let's change that, that's incorrect. You can help me, it's going to be perfect in yours. Solid line are solutions. So just so you know, that should change. Okay, that ends this presentation. Please write down any questions you might have and work on the worksheet that is provided.